Okay, I'm going to do a video here on an example problem with an analog signal being digitized. The analog signal has voltage values between minus 20 and plus 20, and we're going to sample with 4 bits of depth, and this problem is asking about the voltage levels. So in general, you're going to have something that looks like this. You're going to have on a vertical voltage scale, you'll have a maximum voltage and a minimum voltage, and you'll have it divided up into 2 to the n, typically different segments, and then you'll be able to say, well, between the maximum and min, all the voltages will be rounded off to voltage values that are in the centers of each of these ranges. So I did the case where we have 3 bits of depth, and that gives us 8 voltage ranges between Vmin and Vmax, and then we'll have 8 values at which the voltage is rounded off to. So 4, 5, 6, 7, 8. And so basically it's sort of a not too difficult problem to figure out what all these numbers are on the number line as you divide it all up. So let's do this example. Calculate the number of voltage levels in our digitized signal. We use L for voltage levels, and we use NB for the sampling depth, and we say the L is 2 to the NB. Okay, so this is 2 to the NB, and NB is 4. 2 to the 4th, or 16 voltage levels. So it's twice as many as I drew here. So I'll have to draw the picture a little bit larger now if I make a vertical axis. Now we also have to take into account the fact that we're going from minus 20 volts to plus 20 volts. And here's 0. This is the voltage axis. And so if we're dividing this range up into 16, I'm going to divide each of the top and the bottom into 8 and figure out all those values there. And then I'll figure out the midway between each of these. Okay, so, oops, I guess I better divide in half. Divide it in half, and divide it in half again, and half again. So I can get this thing to come out right. It's easier to bisect things over and over again. Okay, so now we've got our voltage ranges, and now we can draw the rounded off values in between them. And I'm maybe not going to finish this whole diagram. In any case, if we have a signal that passes through here, and we sample that signal every so often at our sampling rate, then at each point of time that we're sampling it, this is the time axis, at each point of time that we sample it, we ask which 2 blue lines is the signal between. Okay, so if we look at this very first one here, which of the 2 blue lines is the signal between at this point in time, and then round off to the red line that goes between there. And so I would say that here we would round our signal off. Let me choose a color I can see a little bit better here. The signal at this first point in time would be rounded off to this point on the red axis. At the next point in time, it would be rounded off to this value. At the next value in time, it would be a little bit lower than the actual signal. Here it would be a little bit lower again, and here it would be a little bit lower again. And so these are the rounded off values of that signal, okay, just so that we have a baseline here for what's going on. And now finally I can write down all these values. Well, let's see, if I divide into 16 pieces, so I'm going to do V, I'm going to say that delta V is V max minus V minimum all over L, which is 20 minus negative 20 all over 16, which is 40 over 16, which is 20 over 8, which is 10 over 4, which is 5 over 2, or 2.5. Okay? So delta V is 2.5. So these are all these steps are 2.5. Okay? And that tells us right away, let's count by 2.5. Negative 2.5, negative 5, negative 7.5. Hopefully we end up at negative 20. Negative 10, negative 12.5, negative 15, negative 17.5. Boom. We landed on 20 perfectly. 2.5, 5, 7.5, 10, 12.5, 15, 17.5, and 20. And finally, the red values in between them, they're 1.25 off of the other values, and I'll draw them in here in red and label them. And I would have 18.75 here. I'd have 16.25 here. I'd have 13.75 here. I'd have 11.25 here. 8.75, 6.25, negative 1.25, these are all negative. Okay, negative 3.75, and these are the values that we have. Okay, 1.25, 3.75, 6.25, 8.75, 11.25, 13.75, 16.25, 18.75. Okay, so those are all the values. And it was pretty straightforward to figure those out. The 2.5 was admittedly a nice number, but this is how you can do this problem. Hope that helps.